This video is on the objective use half-angle formulas to find values of trigonometric functions. This is a rarity. This is number 3. I'm only doing 2 videos on the objectives, but there are different classes of question you come across, like several different types, and I haven't done one like this yet, where you're asked to find a specific value, an exact value, not using your calculator. All right. So use a half-angle formula to find the sine of 105 degrees. All right. So I got degrees here that you could change it to radians if you wish as well. Now let me refresh your memory as to what the half-angle formulas look like. And here we're going to be using the sine formula. So this was back in the first video on this objective. I developed all these formulas. Right, the sine of half an angle is plus or minus. Again, the plus or minus, you choose one of these, and it depends on the angle that the quadrant that the angle's in that you're taking the sine of. And then you got a big square root, and then 1 minus the cosine of alpha divided by 2. Right, where this angle here inside the cosine is double the angle you're taking the sine of. The cosine of half of alpha, half an angle, is again plus or minus, and you choose plus or minus. This all depends on what quadrant the angle you're taking the cosine of is, this half angle. Then you have the square root of 1 plus the cosine of alpha over 2, and again the angle in this cosine is double the angle in that cosine on the left. And the tangent of half an angle had 3 different versions. I personally like this second one. So I'll just read that one. The tangent of half an angle, alpha over 2, is 1 minus the cosine of alpha divided by all that divided by the sine of alpha. And again, you can look at the other two if you wish. I personally use the middle one more often than not. Right. Okay, so what we're asked to find here, we're asked to find an exact value. So I'll also use the calculator just to verify that what we've done is correct. I'm going to find the sine of 105 degrees, okay, using a half-angle formula. So another way to write this is the sine of 210 degrees cut in half, isn't it? All right. So back in my formula, the alpha is 210. Right, 105 degrees is half of 210. So the alpha in my formula is 210 degrees. So using this now, you got to think plus or minus. Now think, the angle is 105 degrees. Right, if I draw 105 degrees in standard position, what quadrant are you in? Well, there's 90 and then another, 15 degrees. You're definitely in quadrant 2. Right? 105 degrees is in quadrant 2. And the sine of a quadrant 2 angle will be positive, right? So I'm going to use that plus sign instead of the minus sign. So positive square root, and remember it was 1 minus the cosine of alpha. Now again, the angle in the cosine is double the angle you're taking the sine of if you're using this half-angle formula. So that's the alpha, the 210 degrees. All that divided by 2. And then this cosine of 210, right? Cosine of 210, that's something you should know, or at least know how to find pretty quickly. Right? If I'm looking at 210 degrees over here, if I draw that in standard position, there's 180 and then another 30. Right, there's 210 degrees. That's in quadrant 3, right? Where cosine would be negative, and the reference angle is 30 degrees, isn't it? And remember the cosine of 30 degrees, right? The cosine of 30 degrees, the reference angle, the cosine of 30 degrees was the square root of 3 over 2. Hopefully you remember all those trig functions of special angles, 30, 45, 60, or pi over 6, pi over 4, pi over 3 radians. So that means the cosine of 210 is negative square root of 3 over 2, right? Because it's in quadrant 3, and the cosine of a quadrant 3 angle is negative, because you have negative x coordinates. Remember, cosine was related to x's, sine was related to y's. All right, so I'm going to use that. So the sine of 105 degrees is, again, positive square root of 1 minus the cosine of 210. And we just showed down here the cosine of 210 is negative square root of 3 over 2. And then all this, over 2. All right, so this is a complex fraction here. I'm going to mess with this. I'm going to multiply the top and bottom by 2 to get rid of this 2 down here. Now there are 2 terms up top, so I got to distribute the 2. So we have the square root, and then 2 times 1 is 2. And then the 2's will cancel in the second term. All right, that's the whole reason why I'm doing this, is so the 2's cancel here. So I got minus negative square root of 3, which would be plus the square root of 3. And then all that divided by 4, right? 2 times 2 is 4. And then, the square root of 4 is 2. If I do the square root of the numerator, square root of the denominator, I'm getting the following. All right, so we get the sine of 105 degrees is the square root of 2 plus the square root of 3. So you have like a square root within a square root. And then all that divided by the square root of 4, but the square root of 4 is just 2. All right, so again, make sure this 2 down here isn't inside the square root, because I took the square root of 4 as just positive 2 down here. And there we go. And let's double check this. I'm going to use my calculator to verify that I have done well. So I'll pull the calculator up. Now this is degrees, right? So I'm going to make sure I'm in degree mode when I enter stuff. So I hit the mode button, make sure this radians here, make sure I'm in degree mode. All right, so I'll punch in the sine of 105 degrees. And you're seeing the sine of 105 degrees is 0.9659258263, blah, blah, blah. All right. Now, I'm going to enter this expression I got here after using the half angle formula. So I have a numerator, which is the square root of 2 plus the square root of 3 inside. All right. And then all that, make sure this is outside the square root divided by 2. Right, make sure that divided by 2 is outside the square root. And hopefully I get the same thing, and look at that. 2.9659258. It's the same value. So I must have done well, right? Don't use the calculator straight up, because it doesn't want decimals, right? When you go back to the website, it doesn't want you to enter a decimal. It wants you to enter that square root thing. So it's the square root of 2 plus the square root of 3, and then make sure you get out of both of those square roots, and then divide it by 2. That's what it wants, right? It doesn't want decimals. But you can use your calculator and the decimals and whatnot to verify that you've done a good job using the formula. And wonderful. Great. All right. Again, they go through the same crap I showed you. And again, you choose the plus or minus. It's like, oh, hey, 105 degrees, that's in quadrant 2. The sine of a quadrant 2 angle is positive, so I got to take the positive sign. I personally like to choose the sign first. They wait until the end to choose the sign, but whatever. Right, you end up with the same thing either way. Alright, so hopefully watching me do this, or looking at the more instruction for this, help you when you're working on these kinds of problems on your own. And thank you very much for watching.